now you can control the.
Okay, good afternoon, everybody. Welcome back to Discrete Math. Plan for today is undetermined, apparently. Plan for today is you all have presentations for me on indexing sets, and then I've got another worksheet for you. This time, I'm writing proofs relating to sets. In particular, how do you show two sets are equal? I've got my usual office hours in the next couple days. Right after class today, tomorrow from 10 to 11 and 1 to 2. As far as homework goes, you have a proof portfolio entry due Friday, and presentations Friday on the worksheet. Okay, so first of all, I have an apology for you. I was planning to finish grading the proof portfolio problems from last Friday to hand them back today. As you can see, I have not. Blame a certain student who showed up for a 3-hour conversation yesterday.
What? Here were you? I'm here for it.
Can you give us their initials?
Wait, you supposed to be like.
If you give their initials, you could probably figure out who
Just the name.
Yeah.
Are they in this class?
No.
Okay.
Do I know them?
Anyways.
Yes.
Was it Aaron Jacobson?
I'm going to stop answering these questions.
Oh my gosh, Aaron, I'm gonna go talk to him.
Alright,
Yeah,
so
it
it's
was.
all-
Yeah, maybe it was Aaron Jacobs. Maybe it was. Anyways, what I'm getting at is I will definitely have. I've started grading those. Those I'm kind of writing more substantial feedback on. You're not just getting check marks on the top like you tend to do with your mistake journal entry. Also, if you're submitting your mistake journal entry to me electronically, I'm not going to print it off just so I can put a check mark on it and hand it back to you. It's kind of just a piece of paper, honestly. So you go on Canvas, you can actually see I've been giving everybody scores out of 5 for your proof portfolio entries, so act accordingly. But yeah, next entry is due Friday. I'll hand you back your first couple entries on Friday as well, and then yeah, you'll have your next mistake journal entry for Monday. Any questions or comments before we start the presentation for today? Let's see. Okay, in that case, let's see. If you want to go ahead and go up and start writing some stuff while I circle the rest.
When your name gets circled.
Oh, that's Barbarella.
Added method next time. My name under so many columns.
I'm sorry?
So should we go for added method next time? Put my name under so many columns I don't get picked.
Okay, that's not how that works, but.
Seems to work though.
I mean, last week, ask Holly, last class, she put her name on multiple columns and got selected for 2 of them, so.
I think data points on this.
I mean, there are data, well, I'm not keeping track of, anyways, there you go.
You're doing great.
Thank you.
Hard. I like the green chalk.
Yeah, I kind of am a fan of the,
With green on green, it's very artistic.
thank you. Okay, so, first we have I'm Jacob, I'm doing the first page. This is our,
Question for the class before Jacob goes any further. Is it okay at this point if everybody doesn't have to keep introducing
Yes,
themselves?
please stop introducing
you know
yourself.
what, here's the deal, first time I came up presented, I had to, so now I feel like I'm gonna keep
You can
going.
introduce yourself if you'd like.
I'm Jacob, and we'll be doing the first page. So this first one is the intersection of all of them. So this is like the and. So it has to be in all of them. And if you go to the top of the page, the set is the first part. I don't know if there's another notation to write it out so you see what they all would be. And this is an interval. So as you keep increasing the subscript, the second value and the end of your interval keep going up in the denominator. And so if you have that increasing, what's happening to your interval is it's actually shrinking. So the only value that's in all of them is 0. So the intersection and then for this next one, we have the union for all of them. So now this is like the or statement. So it's in the first one, or the second one, or the third one. And so this will now include, you're gonna look for the largest interval, and that will be this first one. So it would be the interval from 0 to 1. Are there any questions? Yes?
Just like a general one, but so is that the notation we should be using?
Yeah, I that's good. I'm not sure on this. Since the original sets are actually an interval, it's not like these are just entries, it's all of the entries between those. Yeah, Dr. Gersel.
So when you talk about the union, like the set containing everything that's in any of the I sub j's,
Yes.
do you want your set to have one element in it or infinitely many elements?
That's where I don't know I guess it's infinitely many, but
Because right now it looks like you have a set with one element in it.
well,
Which is
it's
the
not,
interval.
it's one element, but the element is an interval with infinitely many things in it. So I don't know what the right way to write it is.
I guess I think you probably don't need the outer brackets, because
Well, I get what you're saying.
because that I think would be saying that like the only thing in there is I sub 1, but what you're actually saying is that like everything is within that. So
If I sub 1 is everything that there is though, does it matter?
Well, do you want to have a box with all infinitely many things in it? Or do you want a box where the only thing inside of that box is a box with infinitely many things in it?
So you're saying this one has a box with infinitely, and then
That would just be a box with infinitely
infinitely many things in it? I guess we want this one.
I think I agree. Yeah, we
Okay.
want just the interval from 0 to 1 because that's the set that is made up of all the things from all the individual I sub j's, while discarding the repeats. And since all the elements coming from the I sub j's are just going to be numbers from 0 to 1, your union should be a set that just contains numbers from 0 to 1, not a set containing a set containing numbers from 0 to 1.
Well, it's weird to me because it's not like, because when we originally had went, like our group tried to do it, I was very confused I didn't notice that it was intervals, not like set notation.
Mhm.
That makes sense? So I kind of wasn't even thinking of this as a set. I guess.
Yeah,
I don't see why these brackets, this notation adds the extra box because up here, it's like, really, I feel like we're not having these, if that makes sense.
yeah.
Like when I'm thinking about it,
I would say that the closed bracket says the interval from 0 to 1 is itself is itself a set. So I would read off that interval that you have for I1, let's say, and read that as the set containing all numbers from 0 to 1 including the endpoints.
So if we wanted to write this using the set notation that we've used previously, could we do the curly braces with an x colon 0 less than or equal to x less than or equal to 1? Or does that denote something?
Yeah, I think that would work. So you're saying for x such that x is like this? Yeah, that's probably a better way if you really want to use the curly brackets.
I think that would be another
Good job, Helen.
equally acceptable way to write out the answer to that one.
Okay.
Yeah, I would say that those are exactly the same as sets, just different ways of writing out the same set. Any questions? Okay. Okay. Next we have Griffin. Sketch a few graphs for us.
Yes. Nope, I'm not even gonna do it.
It's still good to say hi.
Hello, well, I was going to complete that with my newest version, but. Okay, so, I will be doing the first problem on the second page, which has let S equal to infinity. Yeah, I think the next sentence is just saying what that says in words. I'll just write it out. The interval the interval of all real numbers is x where x is greater than or equal to 2. And so we are now defining a set within this set S. So we have for each, man, my board right now just gets worse and worse. For each S that is a member of S, the set is defined as C subscript S is the set of X and Y of the real numbers in 2 dimensions, so like the XY plane pretty much. Where X squared plus Y squared equals S squared. And and you will recognize this to be the equation for a circle, which is very helpful in the next step, where it asks us to graph C sub 2, C sub 4.5, and C sub pi. And so pretty much all this was a graph of a circle with a radius 2. And one thing our group discussed when we did this was whether or not this needed to be shaded. And our reasoning for this first graph was that 2 could not be shaded for a few reasons. A, because it says equals to S squared, not less than or not less than or equal to. Do I have my sign right?
Yeah, good.
Okay,
Well, that would
thank
like
you.
shade the inside, right?
Yeah, that would shade the
Flipping
inside.
it would do the.
Yeah. So it does not have this, which means that it's just the circle, as well as this set begins at 2. So you can't shade the inside. inside of that. And then the next one is 4.5, which is just another circle with a slightly larger radius, again, not drawn in. Then the last one, we have pi and pi. So yeah, that was it. Any questions? All right, thank you very much.
Alrighty, next up, Griffin. So next up, we're going to be looking at the intersection and union of all these sets with Lori.
Hello, I'm presenting the next problem. So now we're finding the sets, the intersection of S and S, of CS and, the intersection and then the union of S and S of CS. So we're gonna start with the intersection, and I said this equals the empty set because there's all the circles are different, so there's no like overlap between them. And then the graph will just look like that. And then the union would be XY and R2 such that x squared plus y squared is greater than or equal to 4. And I said this because the smallest circle has a radius of 2, and then you can make circles that are like infinitely close to that, and then it just like keeps going. And then the graph would just look like that. Does anyone have any questions? Yes.
Okay, so for the second one, I had x squared plus y squared equals s squared for some s is in the set S. Is that saying the same thing?
Can you repeat that?
Sorry,
Can you maybe like over to the side, like would you mind writing down what you just said? I think that would make it a little easier to see with it written down.
So like the capital S set is like the interval from 2 to infinity, right?
Yeah.
So so I have x squared plus y squared equals s squared for some s is included in S. So I think it's the same because if s is included in S, then it's automatically going to be at least 4, right?
Yeah, I think that would work. Any other questions? Yes.
Question for the class. Does anybody like have a preference for the way Sophie did it versus the way Lori did it?
I think it's easier with Lori's,
Yeah.
because then I don't have to refer back to big S,
Right,
but
yeah, like I guess the question is, do we want to refer to the indexing set, right? And do we? I don't.
I think the only preferability about the notation in blue is that you keep the original equation But then you can just refer back to the set if there's no changing of the like inequality sign or something, so.
I agree with Holly.
Does the blue seem to suggest though that it's going, like when you plug things into that equation, you're still gonna get a circle, whereas the yellow equation makes it clear that you get like a bunch of area? Am I just reading the blue incorrectly?
It's a little clear.
Oh, I see what you're saying.
Like either way, you're just getting infinitely many circles that end up being that area because they're like infinitely many.
Does the for some need to be like for all?
I would say for all would actually make it incorrect, because x squared plus y squared can't be equal to multiple values of s squared at the same time.
For all would be the first one, would be the intersection.
Yeah, and I agree that that would give the empty set, as Laurie said. So yeah, I think, so my personal opinion is that, I think Sophie, I think what you had is mathematically equally valid and equally correct as what Laurie had. I do think I like Laurie's a little better because it is a little bit more explicit, as a couple of you mentioned, in terms of what it's defining. Sophie, with yours, it would kind of, just looking at that set, you would have to refer back to, oh, what's the indexing set again? Whereas with Laurie, it's just all self-contained. You can see what it is. But from a mathematical standpoint, I think both ways are equally valid of writing that out.
Can I erase it?
I just want to point out that the way you did that makes it look like kind of like an omelet almost, like an egg. And that makes me hungry. All right, nice job, Laurie. And Sophie. Okay, yeah, nice job. Okay, so next up on page 3, we have Alex.
So on page 3, we're asked to consider 3 sets. This omega set is the set of all x such that x is a student at Hillsdale. Then C sub x is the set of all countries that x, so some specific student, has visited over the course of their lives. Okay, and then finally, big W is the set of all C, level C, such that C is a country on Earth. All right, and then we're asked to consider the elements of the following sets. So, first one is this. Alright, so this is going to be the union of all C sub x where x is an element of omega. So what this is asking us to consider is what's the union of the set of countries that all students at Hillsdale have visited, since x is arbitrary, right? And so if you think about it sort of this way, or if we just take like a concrete example, say student 1 has visited A, B, C, D. Student 2 has visited B, C, D, E. If those are the only 2 students, and we're considering the union of the countries that they visited, then it's going to include A, B, C, D, and E. And so, in order to describe those elements, it would be, what I had was, one way to do that is all the countries had at least one student at Hillsdale. Over course of their lives, okay? Any questions about that one? All right. The next one is the intersection over a similar spectrum of data, or a similar spectrum of elements. So in this case, we're considering the intersection of the set of all countries that all students at Hillsdale have visited over the course of their lives. So in this case, if we go back here, S1 has visited A, B, C, and D, but S2 hasn't visited A, and S1 hasn't visited E. And so if we're considering the intersection, it would be B, C, and D, B, C, and D, right? And so this is going to be all the countries that every student at Hillsdale has visited over the course of their lives. Okay, any questions about that one? All right, and then we have now to consider.
Actually, I think the next two I was gonna leave for the next presenter, if you don't mind.
Oh, oops, sorry. Okay, then I'm done.
Yeah, next time out. Done and eager for more.
Yeah.
Yeah, I really like your example that you kind of drew over to the side to help illustrate the point there. That was helpful for me.
Alright. So. Yeah.
I had $1 for every time I've done that.
Be rich.
I would have a lot of them.
Alright, so the next one is the intersection of x's and omega of c sub x complement of set w. So c sub x is going to be the countries that some student has visited over the course of their lives. A country that some student has visited. And so, excluding, so the set W, we are going to kind of look at that set and subtract C of X from that. So that would be the country, or the countries in the world that a student hasn't visited. And since this is the intersect of that, that's going to be, okay, so like, I know my answer. Explaining how to get there is a little tricky. So I guess an explicit example would be a student has not visited 8 different countries, and another student hasn't visited 9. Oh my gosh.
You have a lot of moving pieces in this one.
Yes, I am not the most organized in my thoughts. How do I explain this?
You maybe write down what your answer is and then explain how you got to it.
Sure. So my answer for this is, this is going to be countries that no still college student has visited. And, alright. So the intersect must include, everything in these sets that overlap. And since this here describes countries that a student hasn't visited, this must include all the countries that no student has ever visited, if that makes sense. Are we good to move on to the next one? Okay, sick. Alright, and then this one's a little bit different. Parentheses are just in a different place. X is in omega, C sub x, and then the complement of W. Very again. So, again, I'll go straight to my answer, where it's countries that not all still college students have visited. So in this case, we are looking at C sub x, which is going to be countries that your students have visited, and this is the intersect, so it's only going to include countries that all the students have visited. For instance, probably like the USA is going to be the only country that every single Hillstone College student has visited, so that's what this is going to include. And then the complement of W, all the countries in the world, is going to be the countries that not all students have visited, which is pretty much, if I had to guess, gonna be all countries except the USA. Yes.
So that last one, the second one that you did,
Yeah.
is that kind of the same thing as saying the third one, but instead of the intersect, the union?
So you're saying that this is equivalent to this? Is that what you're
Yeah,
saying?
that was my question, yeah.
Let's see. So take the complement. This will be countries. So all the countries that just. Actually, does someone else want to field that? Because I'm a little bit stuck.
Referring back to our theorem in 2.4.9,
Oh boy.
Morgan's law states that those would be equivalent, so yes.
Spoilers for today's worksheet.
Yeah.
Would you mind drawing, pictures of these?
Of countries or like?
You're on
World
accurate map
map.
of the world.
Because I thought that.
The Venn diagram.
No, but would you be willing to do the Venn diagram for both of these?
Sure.
Sorry, I'm very.
Would it help if I went to the room 111 and pulled up a sphere so that she could draw countries on a sphere for
That
us?
would be so wonderful.
Wait a second, I thought there was something like that in here. There was.
There's, I think someone else has it right now.
Okay.
Probably Dr. Moore.
So, okay, what sets do we have?
Maybe for just like set like two sets, like assume there's a C1 and a C2, just to
Yes.
avoid making this too
I
complicated.
guess.
C2. Alright, so are we thinking C1 is like student 1, C2 is student 2?
I think it's country one and
Or
country
country.
two, that's student has visited.
It's like, yeah, it's groups of countries.
I think if we just want a Venn diagram, if we want to see like, it doesn't really matter what C1 and C2 represent, but the intersection of the complements of C1 and C2 versus the complement of the intersection.
Whoa, that's a lot of math. What?
Cool.
Okay, so like, I feel like if we have like the box, isn't the box like set W? This is like country 1, country 2. Is that fair? Cause that's what I think of when I see the complement. But maybe that's wrong.
I think you're good.
Okay. So, see, oh my goodness. C sub x is going to be a set, so C sub 1 is going to be all the countries that a student has visited, so you're going to have like A, B, C, and then this is a set of countries that another student has visited, and you got like C, D, E, so obviously C is in both. And so in this case, we are looking at C sub x, and we're looking at the complement. And okay, so let's do FGH, because those are other countries in the world. So we're looking at C sub x, which is going to include not just C1, C2, but C3, C4, etc. But for example, we just have 2 here. And so we are looking at something that is going to be outside of both of these. So something that's going to be outside of C1 is going to be C, D, E, F, or it's going to be D, E, F, G, H. And something that's going to be outside of this circle is going to be A, B, F, G, H. So the intersect that encompasses all of this is F, G, H, which happen to be in the set countries in the world, and they happen to be countries that no student has ever visited. Or, yeah, none of our students in our set.
So it doesn't include A, B, D, and E, and C?
Correct. So, yeah, countries that no Hillsdale College student has visited. So if it is a country that a student has visited, it's immediately excluded from the answer because it's in, someone's bubble.
Thank you.
Yeah, of course. I was thinking of it too.
Okay, so then the difference for the bottom one where the parentheses are outside of the intersection line, with that on the Venn diagram, would you color in everything except for C?
Yeah, in this case we would. So that's why this one is a very, very like narrow, tiny set, because it would have to be like overlapped by all the circles. If that makes sense. We're looking first at the countries, the C of X that all students in Omega have visited, which again is either going to be like an empty set or just the USA or something like that. And then we're looking at W and figuring out where in the world have not all students visited, and the answer to that is a giant set. Yes.
So, in order to be a student at Hillsdale College, does Omega include students that have just taken, or people who've taken like an online course or two?
That's not relevant, I don't think. Is it?
Well, I guess it's relevant to determining whether the countries every Hillsdale student has visited includes the USA or not. What if you're someone who never left Europe and you've taken an online class?
Oh, okay, well in that case it's the empty set.
Okay.
I was just saying USA for simplicity, but it could be wrong, so.
I'm sorry, now I'm just being mean.
Oh, no. No, it's good to consider.
Any other questions for Laura? Nice job. Yeah, those last couple were definitely tricky. Lots of moving pieces. You have intersection, you have X, you have omega, you have C sub X, you have W, you have complements. There's a lot of moving pieces there. But yeah, I thought you did a really good job. And Griffin, I'm glad you asked about what would that look like in a picture, because especially for sets that are getting this complicated, I definitely feel that having Venn diagrams can be helpful to me in understanding what the heck is going on here. Okay, so got another packet for you. This one involves some proofwriting, where we're going to be looking at things like De Morgan's laws, Holly, and seeing what does it look like to prove some things. So in this packet, basically in order to prove, the moral of this packet is to prove two sets are equal, you show that each one is a subset of the other one. That A is equal to B if all elements in A are also in B, and if all elements in B are also in A. And so in this packet, you're going to get some practice writing out some proofs of that. So let's see, how to do it this time. Raise your hand if you consider yourself to have blonde hair. Say some of you, I feel like are definitely some of you I would consider a borderline.
No.
Okay, well, we have a group of 3. Light colored but not blonde hair. Okay, group of 3. Brown hair.
I would understand if I was put in the black category.
Let's go with Adam, Alex, Sophie. And then Mariah, Laurie. You can join. You can form your own group if you want, or if you want to join another group, that's also okay. Okay, and
I got you.
Oh, you guys are so nice.
I was gonna make her move, I'm not gonna.
Yeah, I know you're not.
I was like, no.
Sorry, everyone moved it down. I always use pencil. I love the
Alright.
That's a lot of time.
I mean, you don't have to be that bold to use pen, you just have to think that you're only gonna do one out of
You want to pick that back morning?
I'm thinking this might be a lot. This is like a lot of writing.
Yeah, I bet you could be. Dr. Curtis, do you have any activities?
Okay, I see how much, not okay.
This chair is so cold. I guess nobody see how we got away with it.
It's freezing outside.
Okay, this is.
I'm not writing this. I can't read this. It's not.
So try not to be too intimidated by what's going on here, especially on this first page. I thought I'd give you a full example, but see if you can understand each sentence one sentence at a time. It's going to be my suggestion. Don't try and go through the whole thing all at once. Go see if you can go slowly through it.
What is the symbol? The first.
Like if A is
Is it something that's a subset of?
I think I can understand, like, if X is in A, then X is in the union of A and B.
The following example makes house
Is in
of
the union
proofs
of A and
make up.
C.
For all set A, B, and C. A. Intersection. Oh my god, A union, intersection B, intersection C. Actually, I don't know what that was.
okay. I feel like we already learned this.
Isabel, we've already learned this. You ready to present right now?
Oh yeah, for sure. No, I feel like I remember like reading this like just the distributed, not distributed property, but like I don't know.
No, actually, you could call that the distributive property of the union.
I also might have just read
I
it as
said we just like,
probability, though. I don't know if I read it in our
like,
book or
when it
not.
goes bad.
It's in section 2.4.
Ah, makes sense.
Maybe.
It's basically what we did in abstract.
Yeah, literally today.
So much.
Now try to show this is the subset of this take
So, yeah, I was like thinking about, I was wondering if we were going to get to something like this, because for that, one of these group portfolios from this last worksheet, we do need like.
Yeah, for number 2 in that one kind of fits more with this than with that.
That's crazy. Wait, why is it like that?
Alright.
It might have been left over in the printer.
That has to hire.
That was proven distributed oral intersection, I guess.
Got a water?
Yeah. Okay.
I made it to the
Yeah.
first.
The first one.
I made it to that.
Oh,
Makes sense.
Alright, guys, we're
I'll let
great.
Ms. Crenshaw know her printer does that.
So mad.
And then if X is an element of that intersection, then it's
Okay.
an element of both.
So we need to prove
Yeah.
that
Very simple.
It has to be, in either this one or that one. There's elements of,
well, I think we would start by proving that A
Was
is
this called the transitive property
is a
where you
subset
like trace
of
the
A.
elements of this into this?
oh, it's intersection of. Yeah, so what if we do?
I did not read the book. It was from class.
Oh, Friday.
Did you get, second paragraph?
Yeah.
Dr. Crystal,
I'm willing to skip the next one
was
because
the thing where you like have an element in here and
Yeah, I
then
just-
show
I
how
like
Oh,
it's
yeah,
an
it's
element of
just-
that, is that something?
I feel like we can just try.
Well, that's more just like what it means for the first set to be a subset of the second. If you can take an arbitrary element in here and show that an arbitrary element here also has to be in here,
Also, I
that
think
proves the first set is a subset of the
Yeah,
second set.
great.
that we,
The transitive property, I think, referred to the thing where we said if A is a subset of B and B is a subset of C, then A has to be a subset of C if you have sort of three sets involved.
Oh, that's true,
This
that's
is
true.
like the
So,
second.
if we say let X equal.
Oh, I see.
So we're gonna say that X is an element of B or C. And since it intersects with A, it's also an element.
Has to
of A.
also be a member of this set. And
That makes sense. So I think we can first start by saying X is an element of B, U and C.
Honestly, I would not mind
And since
meeting up sometime before Friday.
Okay, so the premise is simple, like these two
That
combined,
is
whatever
intersection
crosses
with A.
over from A into those combined is gonna
X
be
is a,
the combination
Oh,
of
then it's
is
also.
what's in both of these and what's in both of these.
So we have to prove that.
I'm gonna draw
right?
I was gonna say, I was just about to say, if you're having a hard time illustrating this first theorem,
Okay.
drawing a picture and or with Venn diagrams might be helpful.
So we have A, B, and C. And so the first thing we have is the union of A, but it has to be intersection of C, so that's just like this little.
I mean, I'm sure it makes sense, I just haven't. Sense of
Doesn't necessarily make sense immediately.
X is an element of B.
And so we have the intersection.
I tracked all the way to here and then I got stuck.
I'm sorry, like,
Intersection of
yeah,
A
X
and
is
C.
equal.
Are you already on union response?
So for this one, we have.
Wait, should actually
A
do like
which is
the
that.
whole
The
thing,
intersection of A.
because then you could say either
This is
X
just like line
X is both an element of A
Oh,
and also an
and then,
element
and
of
so this is.
C. I don't know if that
Yeah,
helps,
so
though. Like, you can make more of a statement with that. Because you just know that X is in the union of B and C, you don't know if it's in like B or C.
Yeah.
You just know it's in the union.
And this, yeah, this
So
X is in D,
sorry, this
you
is
see,
that side.
you would need to split it up into two cases and say, if X is in D, show it has to be in the thing you want, and if X is in C,
Yeah. So.
you would have to have a slightly
so
different
then
argument to show it's
C,
the thing you
so
want.
like B, like that right there, all of that.
That's my brain.
And then.
Definitely
or
tricky for stuff,
A.
first
But
two
if
times
you
through.
wanna combine
Wait,
it,
did I do it backwards?
So this is whatever's in both and
A or
like,
and A or
join with the X
So
of
like an element of A, not
Yeah.
B or
That is
C.
good.
So this side is right. Yeah, this side needs to have.
And we're letting it exactly the same, so we're able to say.
Just like all of these presentations.
I'm like practicing.
What?
And then intersection A. Oh, yep, they are the same, and then it just took me a moment to get there. Yep, okay, so we now proved that they are in fact the same.
That's my proof.
Like circles.
Proof by Venn diagram does not constitute a proof.
So I guess how did we get there?
Suggest an example.
We first shaded the part of A and B, and then we
Oh, so
shaded
you'll
out
start
the
off.
part of A and C.
I think
That's
that.
how we got
Gotcha.
here.
I
What was it? What was
I
it?
don't know how to just like
B and
freestyle.
C,
Yeah, that makes sense.
So
You feel
like,
that?
I think so. That's,
Okay.
I think that's smarter.
that makes sense.
Imagine presenting.
Alright, we are actually out of time already for today.
Okay.
But I think it'd be good for you all to have some extra time to think about this, so I encourage you to think about this between now and Friday. And I think for Friday, what I'd like to do is I'm gonna give you all some time in maybe the first half of class to talk about this some more with your partners. And then maybe in the second half of class Friday, we'll do presentations of perhaps this first theorem.
I say you're
On the what?
first person.
Oh, well, thanks.
If you can.
Well, you just have to get the first one.
It's definitely, I definitely think this one's trickier than the last few have been, especially because the proof writing is suddenly gonna get a fair bit longer.
Honestly, once you kind of get your head around what you need to do,
Yeah.
it flows pretty easily.
That's how I feel. It's like getting started, and wrapping your mind around what the process is the hardest part of these.
Yeah, and then it flows pretty easily.
Okay, have a good day, everybody. I'll see you all on Friday.
Yeah.